Let's see how we are going to find a parametric representation of the sphere with radius a, which is given by this equation here. And of course, you can just quote the spherical coordinates formulas, but we're not going to do that because otherwise, where's the fun, right? I want to review how to convert from rectangular to spherical, or maybe the other way around, so that we can come up with the parametric representation for this right here in this video. So let's go ahead and do that. First, we need some pictures, x, y, and z. And let's say we have a point in the space right here. So this is how the spherical coordinate system works. Imagine that we have a fly over there somewhere in my room. And by default, I'm facing this direction and I'm holding a laser gun pointing in the positive z direction, like this. Now, in order for me to get to the fly, I have to make a turn first on my body, like this. So that's the first rotation. That rotation is on the x and y plane right here, and we are going to call that theta, like this. Then I'm going to do the second rotation. I have to do like this, so I can aim my laser gun to the fly, this. So that will be this rotation here. We call that angle phi. By the way, let me just mention that mathematicians and physicists, we label the theta and phi differently, but I'm going to do it like this in this video, and I'm also going over the notation based on the textbook by James Stewart. Anyways, first rotation, second rotation, now I can aim the fly. I'll just have to fire my laser gun from here so I can get to the fly. That, from here to here, is the distance that we need. Usually we'll write it down as rho, the Greek letter rho, but here we are talking about a for the radius, so I'm going to put down a right here. Okay? So, how are we going to get x, y, and z based on these three things though? Okay, let's see. First, the x, y, and z. So this is the x, this is the y, and this is going to be kind of parallel like that. Okay, and then here is the z. Well, we can see that right away. A is just going to be the distance formula in three-dimensional. So a is equal to square root of x squared plus y squared plus z squared, which is really just the same as that. And if you find all points satisfying this equation, you get sphere in the three-dimensional world. Now, the goal is to figure out x, y, and z based on these three things. To continue, we actually need the segment from here to here, and we are going to call that r. And the reason for us to do so is because we can use the polar coordinate systems on the xy plane to help us out a little bit. Check this out. Firstly, if you look at this triangle on the xy plane, so here is the x, here is the y. This is the x distance that we need, and this is the y, and here is the r. And we have the angle theta here. Now, based on this, we know that x is equal to r times cosine theta, and then y is equal to r times sine theta, right? The classic polar coordinates conversion. Now, what is r though? We have to figure out r based on this triangle here. So let's have a look. This is the bottom right here, and then we have the z like this, and lastly we have this, which is a. This angle here has to be 90 degrees because it's a point going straight down to the xy plane. So here we have 90 degrees. Now be careful though. This is how we define the angle phi. Here is the positive z-axis right here. So here is the angle phi. But this and that are parallel. If this is phi, so is this. So now looking at this picture, we have the opposite and also the hypotenuse. We can say sine phi is equal to r over a. Now multiply a, we get r equals a times sine phi. And that's all we need right here and right here. And then we can figure out the x and y. But of course, we also need the z. But z is not bad at all. Z is just the adjacent of this right triangle, which is what? Well, cosine phi is equal to adjacent over a. So multiply both sides by a, we can see that z is equal to a times cosine phi. So have a look. All I have to do now is to put this into here and here, and then z is this already. So finally, I'll just give you guys the final results right here. Ladies and gentlemen, we have x, which is equal to r, which is a sine phi. And we will have to multiply by cosine theta. And then y, it's also r, so that's a sine phi. And then we multiply that by sine theta. And lastly, we have z, which is a times cosine phi. So that's it. This is how you get x, y, and z based on a, phi, and theta. And that is a parametric representation for this sphere here. That's it.